Hello everyone and welcome to our first lesson using Go, the Go programming language. In this first lesson we will look at variables, since you know that the first thing one must understand is how to create and use variables, no matter the programming language. Alright, so I'll do a few things. Going forward, I will not do all of this. I'm just doing it this first time so that you understand what I am doing. So I open up my terminal and I have a directory that I had created earlier, Go code. So I'll go into that, cd go code. Okay, and I'm going to create another directory named variables, since we are learning about variables. Okay, so let's navigate to that variables directory. Okay, and it's empty. And so what I want to do, I want to set up modules. So if you recall, I will say go mod init, and I will give it the identifier. I will say Lewis Dalwin.net / and the name of the directory that we're in, which is variables. Okay, and it tells us that it has created a new module. And now I'm going to create a file using touch main.go. If you have gone through the Linux tutorial video, you will understand how to use touch. Alright, so the last thing that we need to do, that's the last thing we need to do. Well, not quite yet. I simply need to do go mod tidy. Okay. Alright, we're good. So let's open up this directory using Visual Studio Code. So I will simply type code space with a dot, enter. Okay, so Visual Studio Code opens up for us and we have our main.go file, and so now we will start discussing variables. So I need a package, of course, and package main. Okay, when you get the packages, you will understand what the package is all about. Okay, for now just think of package as simply the ability to put many Go files in one unit. Okay, in one unit. So we could have many packages. For example, we could have a package, and packages usually comes in directory. So if you want to create a package, let's say a package that deals with databases, your database code, you'll probably create a package named database. Okay, and inside that directory package, you're going to write all the code that you need that will use your database. Okay, so for now, package is just a way to organize your code. Alright, we'll get to that later on in the course. Alright, so followed by a package name, we need a import, which is sort of synonymous to the pong include in your C++. Alright, so we're saying which libraries, in terms of Go, which packages you want to use, which libraries you want to use. I want to use FMT, okay, because I want to be able to print to the console. Alright, so similar to C++, we have a main function. Okay, and sometimes you hear me talk about C++, just so that it can give you a bit of context, since you have done at least 2 C++ programming courses. Alright, okay, so let's look at creating variables. Okay, notice I'm creating my variables inside of the main function, and your program can only have one main, since your program starts from main. Okay, you call other functions from main, just like C++. Okay. However, as you'll see, Go is simpler than C++. It makes a lot of the features easier to use than C++, and you can become very competent in writing powerful Go programs in 6 months. Okay, as compared to C++, where you might need 2 years. Okay, so creating variables, approach number 1. All right. How do I create a variable? I use the var keyword, and I will follow the var keyword by the name of the variable. Let's call that name, okay, and the type, string. Let's create another variable. This time I'm going to call it open, and the type is bool, true or false. Let's create a third variable named age, type int. I'm going to create another variable of, let's see, named length, of type float 64. And I'm going to create a fifth variable, ptr, which is a pointer to an int. Okay, now notice right away that all my variable names are underlined, and if I mouse over, it says name declared but not used. Okay, so the compiler is saying that you created these names but you're not using them, in your program. So I will say right away that Go is has a very strict compiler, a very picky compiler. It does its best to enforce good coding practices. In many languages, you could create variables all you want and not even use them in your program, and your program would still compile and run. Alright? In Go, that's not the case. Go is very strict to ensure that you don't shoot yourself in the foot later on down the road. Alright? Because if you have unused variables, when you read your code, or when anybody else reads your code, they're going to start asking questions. What is that for? What is that for? How come I don't see it in your code? Okay? So that's one thing you'll see with the Go compiler. It's very strict. Your code will only compile when you have essentially written a good program. Okay, so to get the compiler to stop yelling at us, we will print the values of the variables. Okay. Now, right there you might be saying, I have not assigned any values to the variables, so why am I going to print them? Well, let's see. Remember, Go is not C++. So I'm going to say fmt dot print, and for now I'll just use println. Println just takes the variable, prints it. Right? Well, it's telling me here, right? That's what I like about Visual Studio Code and Go. You get a hint as to what the function is. It prints to the standard output, alright, and of course it returns a new line. Okay, so let's put name here. Okay, and notice, see, the red line has disappeared. It has disappeared because we are using it. Okay, so let's do the same for open. We're gonna do the same for age. I'm going to do the same for length, and we're going to do the same for PTR. Okay. Okay. So how do we run this program? Well, we have a terminal here, so we click on that. New terminal. Okay. So we have our code here that we're writing, and we have our terminal here where we can run the program. All right. Okay. So let's make sure that we're in the right directory. Okay. Right, I have my program there, so I am in the right directory. So now I could say go run main.go. Okay, and notice it gives a space, it gives false, it gives 0, it gives 0, and it gives nil. So if you were to do this in C++, you'll probably get garbage, right? You'll get garbage. In Go, and one way that Go enforces good programming habits, whenever you create a variable in Go and you do not initialize it, it's initialized automatically to what is called the 0 value. Okay, so the 0 value. Okay, if not initialize. Okay, so what is the 0 value? Well, for a string, if you create a string and you do not assign anything to it, its 0 value is simply the empty string, and that's why you have an empty line here, because it's the empty string. The 0 value for bool is false. The 0 value for a float 64 is 0. The 0 value for an int is 0, and the 0 value for a pointer is nil. Okay, so if you just declare a pointer, then Go will set it to nil. Okay. Okay. So that's the first thing you need to understand. What differentiates Go from other languages? It's the idea of a 0 value for variables that are not initialized. Alright, so that's a good thing, because your variables will always be in a consistent state. Alright, you'll always be in a consistent state. There are many programming errors that have occurred because some programmer created a variable, let's say it's in C++ or in any of the other languages, C, C++, Java, whatever, and they did not initialize the variable, and they started using it. Okay, maybe they used it to increment or to decrement or as a counter, and when you run the program it works one time, when you run the second time it works, but when you run it some other time it stops working. Okay, so initializing variables are very important, and so Go does that for us, where every variable that you declare and you do not assign anything to it, Go make sure that it has a 0 value. Alright, so let's try something else. Let's do some more printing. So fmt dot print, okay, ln, okay, on the print let's just do print, and I could simply print let's say 3 lines. Okay, so let's say I wanted to find out not only the value, but what is the type? And so for that, I'm going to use printf. Okay, printf means the f means formatted. All right, you need to provide a formatted string. So I will simply say variable name has value, and I'm going to use a %sign with a v. Okay, and type, what is the type? Well, I'm going to use a %sign again and capital T, and I'm going to say okay, name, oops, outside the closing quotes. Okay, name, comma, name. Okay, all right, so this is what I mean by a formatted string. We have a string, and then we have placeholders. Notice the placeholders have a %sign, and those placeholders will be replaced by what comes after the string, these two variables. Okay, but even though I use name twice, because this is a v, it's going to actually give me the value of the name variable, which, as we know, it's an empty string, right? And when I call name again, it's going to give me the type. Okay, all right, so let's save that. Let's run it, and notice okay, so it gives me on the same line, and that's because I forgot to put a new line. Okay, all right, let's try again. Clear my screen, Control L, and run the program. All right, so notice it says variable name has value nothing, right, empty string, and type string. Okay, all right, so you might be asking now, let me close my terminal. You might be asking now, well, how do I assign something to the variables that I have declared? Well, that's easy enough. So let's assign values to our variables. All right, and so I could simply say name, assignment sign. Notice I did not say equal sign, I said assignment sign, quotes, and now we assign a literal. Okay, so now we assign a literal, in this case a string literal, such as apple. Okay, or maybe go. We could say open, assigned true, small letter T, small letter F. We could say age is assigned the value 14, length is assigned the value 12.5, and PTR is assigned what? A pointer to an int. So let's see, pointer address, sorry, age. Okay, address age. Okay, just remember, a pointer is just a variable where it will contain an address. It's all you need to know if you forgot. Okay, great. And so of course, if I wanted to, I could print the updated values. All right, so I could always grab this. All right, let's Let's put some spaces. fmt.print \n. Okay, and let's open my terminal, and let's say go run. May not go. Alright, so we had the original 0 values, and then we had some space, and so now we're going to print go true 14 12.5, and of course we have an address, right? Because remember, as I said, a pointer is just a regular variable, except it stores addresses. Okay, it stores addresses, and there you have an address. Okay, so that's how you create variables. Now you might be asking, can I create variables and initialize them at the same time? Yes, you can. So we will do approach number 2. Create variables. Approach number 2. And so we can do something like var moniker. I could say string, and then I could say maybe Jane. Okay, once again, I'm not using it, so I could say fmt that print line moniker. Okay, let's put some space so that we don't get confused. Okay, and so go run main. Oops, let's try again. Go run main. Alright, and we see Jane. And of course we can do this for any other variable. So we create the variable using var, declare the variable using var. Okay, we give it a name, give it a type, and then we assign a value to it. We could also do this. We don't need to put the type. We could say var count assign 23. Okay, and then I could simply say count. So I could skip the type. Okay, all right, I could skip the type. All right, and so Go will infer that this variable is of type int. Okay, is of type int, and we can clearly see that by checking. Okay, so let me grab this. Let me grab this, and we can show that Go infers the right type. So variable count has value something and type something. So we're going to use count here, and we're going to use count here. Okay, alright, so variable count has value 23 and type int. Alright, so the compiler infers the right type. Okay, so this is approach number 2. Is there another way to create variables in Go? Yes, there is. And this third way, notice I am creating these variables inside main, right? Okay, so this is another approach. However, there is a restriction to this approach. The restriction is you can only use this approach inside a function. So you can use this approach inside main or inside some other function that you create. You cannot create variables using this approach outside of a function. Alright? You can't. Okay. So this is called the shorthand notation. Okay? Shorthand variable creation notation. So all you do, you create a variable and you assign something to it. So for example, I could say width. Okay? Notice I'm not using the var. So I'm going to say width, and then I'm going to say colon equal, and then I'm going to assign a value. 37.8. Okay? This is shorthand notation. This is very useful when you are getting values back from a function call. Okay? So when you call a function, for example, you had a function get name or something, get name. Okay? Right? So whatever the function returns, you can just say colon equal assigned to a variable, and whatever type was returned by the function, width will have that type. Okay, so we see this a lot in Go code when you're calling functions and you don't want to create a variable that says, okay, this is the type of the function that will return, and so I'm going to create a variable. Okay, so if you know the variable returns, let's say an int, yes, you could say var maybe width, okay, is assigned get whatever, get width. Okay, all right, that's a lot of work. What if the person changes the function and they say now that the variable, sorry, the function can return a float? So it means you might have to change a function, right? Sorry, you might have to change a variable. Okay, in this case you don't, but if you had done it this way, int, then yes, you have to change it to float. Okay. Okay. So to avoid all of that, we use the shorthand notation. Simply give a variable name, colon equal, and whatever. Could be a function call, like get width. It could also be variables, like result maybe. Or it could be a literal, such as 54.6. Okay? The idea is you do not have to specify the type. You do not have to use the var keyword. Okay? And you can, of course, print it. Yeah. Alright. You will see this a lot. You will see the shorthand notation a lot. Okay, just remember, all it's doing is making it convenient for you to not have to declare the variable before assigning a value to it. Now, the only thing is you cannot use shorthand notation outside of a function. So if I come out of main Alright, and I decide to create a variable, and I say x colon equals 7. Okay, that's shorthand notation. Alright, but it's telling me expected declaration. Right, it expected a declaration. It expected a var, or it expected you not to use the shorthand notation. So whenever you see that, you cannot do the shorthand notation outside of a function. Okay, you can do var x equals 7, no problem. Alright, you can do var x int 7, no problem, outside of a function, no problem. But you can never use the shorthand notation outside of a function. Alright, that will be a compile. Go will not allow you to compile your code. Alright, so I should say okay. That's how we do shorthand variable notation. You'll see this a lot in Python, in Go code. And there's one other thing I want to discuss about variables, and this is extremely important. Okay, so bear with me for a couple more minutes. Type conversion. Okay, in other languages, you can create a variable, let's say an int, and you could probably add it to another variable of type float. So let's say x short is 12.3, y is 7. Okay, and then you would do something like say fmt dot println x plus y. Right? What is it telling me? Invalid operation, mismatch type, float and int. So in other words, so let me make it more explicit for you. Let me put z is x plus y. Okay, oops, x plus y. So it's telling me that I cannot add a float 64 to an int. In other languages, that would be done for you perfectly. In Go, Go does not allow you to willy-nilly deal with different types. Okay, so there is no implicit conversion. Right? By implicit conversion, I mean when you say z is x plus y, behind the scenes, C++ might convert one of these, convert the y to a float, and then add to get 19.3. In Go, Go does not do it implicitly. You have to be the one to tell Go that, you know what, Go, I created this variable y, which is of int. However, I need to add it to an x, which is a float 64. So I want you to help me by temporarily converting it to a float. So I'm going to say x plus y, and I'm going to say float 64. I'm going to say y. Okay? So okay, great. So it's telling me it's wrong. Okay, so anybody can you think about it for a minute? Why is line 57 giving me a compile error? Remember what we talked about, how to declare variables? Okay, so think about it. I did not declare z properly. Why? Because I should have said var Z, but I could have also said shorthand notation. Okay? Okay, I hope you saw that. So, I have my x, which is a float, and I have my y, which is an int, but I will temporarily convert the y to a float 64, and then I will add the two values and place it into z, which will now be a float. Okay? Now, do not forget, y is still an int. I am only temporarily converting it to a float. So if I were to check the type of y again, it would still be an int. Okay? Alright, so this is what I mean by type conversion in Go. At the beginning, yes, it might feel a bit strange that you have to always ensure what types you're working with, but it's done this way because it forces you to think about what types you're working with. All right, in many languages such as Python, JavaScript, C++ to an extent, you just write code and you completely don't think about what you're doing, what types you're using. Can this type work with that type? Will I get truncation error, meaning will I get the decimal point chopped off? Alright, so those are things that in other languages you have to find and fix because they are usually bugs. Okay, but in Go kind of puts that in front of you at the start, so that chances are you will not be having that kind of error in your code. So yes, it takes a bit more effort on your part, but it saves you on down the road because you know that you have done the conversions properly and you got exactly what you wanted to get, and you did not leave it up to the compiler to implicitly convert things from one to the next for you, which you have no idea what is happening. Alright, okay, so this is all you really need to know about variables as it concerns Go programming. There are some more details, but as you work with the Go language, I will explain some of those details. For now, you don't need them because I don't want to bury you with too much details. Alright, so that's it for this first lesson. So my advice to you is to watch the lesson the first time and then go back over it and open Visual Studio and start writing the code yourself to get a feel for how these things are done. Alright, I will see you in the next lesson where we will look at how to create a very important type in Go, which are called structs. Alright, we see them all through Go code, and so it's important that we learn to use them from the start. I'll see you in that video, in that lesson.